Hey guys, today we're going to start looking at how to solve quadratic equations. And so I've got this broken into really 3 different lessons. So the first one that we're going to look at today is how to solve quadratic equations using a method called square roots and then by completing the square. So solving a quadratic equation is an equation that has an x squared in it. So that would be like those trinomials that we used before where we were doing x squared plus 3x plus 4. So if you have that equal to a number, that's an equation that we're able to solve. And so we've got to be able to figure out how to solve that 4x without being able to combine the x's together, because we can't combine an x squared with a 3x. And so we're going to look at some methods for solving that that'll allow us to get our answer to that. Interesting thing about quadratics is they all have many of them have 2 answers that would work for them, because you have an x squared, and that x squared allows for 2 different answers to be possible in a lot of situations. And so for most of these, we will be able to get 2 correct answers to each one. And so we'll have to look at how to make that happen as a result of the solving process. So by the end of this, you'll be able to solve quadratic equations using square roots and by completing the square. So let's go. So let's talk about the first method of using square roots. So we do square roots anytime we have a quadratic equation in the form of x minus h squared equals k. So it doesn't have to be an x minus h. This could possibly just be like an x squared. But that's the basic format. So if you have a portion of it that is squared and it's equal to some number, we can do square roots with it. And so first thing we want to do is to isolate the squared term on one side of the equation. So if it's not already that way, we're going to move whatever's squared to one side by itself, move whatever's on that same side with the square to the other side, so that it has the squared part by itself on one side and everything else on the other side. Then once you get that worked out, you're going to square root both sides of the equation, because we can cancel a square using a square root. Square root's the inverse of squaring a number. You hopefully remember, because you would have done some of these in 8th grade math, where you were solving like x squared equals 49. And so you learned how to solve that by finding the square root on both sides. And so you learned that x would equal 7. But hopefully you remember when you learned that x could also be negative 7. I didn't mean to make that over there. Because 7 times 7 is 49, and negative 7 times negative 7 is 49. So all numbers have 2 square roots, or all real numbers have 2 square roots, one positive and one negative. And so once you figure those 2 numbers out, you can finish solving for x. Sometimes you'll already know it. Sometimes that'll be it. But if not, you may have to finish solving for x, and then you're going to want to simplify any radical expressions that can be reduced. So what I mean by this is, if we had something like x plus 3 squared equals, I'm just going to make this up and say 4. You could solve this by, first of all, we want to make sure that the squared portion of our equation, the squared portion of our equation is by itself. All of this is squared. All of this is already alone, so this is good. Squared part's alone. This part's over here. So now to get rid of that square, to undo that square, we could use a square root. Remember, what we do to one side, we have to do to the other. So the square root and the square cancel out. That leaves me with x plus 3. On this side, the square root of 4 is 2, but it's also negative 2. And so we're going to have to work off of both of those things to be able to get an answer to this problem. So I know that x plus 3 can equal 2 and x plus 3 can equal negative 2. Now you could, if you wanted to, come over here and do x plus 3 equals 2, x plus 3 equals negative 2, solve both of those separately. I personally would rather not rewrite that over there. And so I like to just take it from here, draw me a line to kind of separate my 2 possible answers, and then do my inverse off of that. So if I know to move the plus 3, I would subtract 3. I'm going to subtract 3 from both of those possible answers at that point. And so my x comes down. And so that means that x could equal 2 minus 3, which is negative 1, or negative 2 minus 3, which is negative 5. And those could be our two solutions to that. So we've isolated the part that's squared. We found the square root on both sides. And then we finished solving for the x. That's how we do square roots. So let's do some examples of this. So you could have really simple problems like this one, where the variable that is squared is already by itself. It's already isolated. So the only thing we can do here to get it by itself or to finish the problem out is to do square roots on both sides. So the square root of k squared, the square root of 16. Square root of k squared is k. So k will equal the square root of 16. Well, the square root of 16 is 4, but it's also negative 4. So the two answers to this are that k could equal 4 and k could equal negative 4. Now, if you have one like this, on this one, the squared part is not isolated yet. Notice that this is the piece that's squared, but there's a plus 8 attached to it. I got to move that before I do anything else. So before I try to square root anything, whoops, I'm going to move that plus 8 by subtracting 8. So I end up with x squared equals 20. Then we'll turn around and do the square root to cancel the square. So the square root and the square cancel out. Gives me just a plain old x on this side. If you go calculate the square root of 20, you're going to find that it's some crazy 4-point craziness number. So what we don't want to do is write that as a decimal, unless a problem specifically tells you round your answer to the nearest whatever. Typically, we're going to leave it in radical form if we get a number that's not a perfect or a nice, pretty, round decimal number. Problem with this, though, not really the problem, but something we need to consider when we're going to leave something in radical form is, can the radical be simplified? And here's what I mean by that. If you've got something like the root of 20, you can simplify a radical by breaking that number into factors that'll multiply to give you 20. And if you can come up with a factor that's a perfect square, you can reduce that part of the radical. So let's think about what our perfect squares are. 1 times 1 is 1, 1's a perfect square. 2 times 2 is 4, 4's a perfect square. 3 times 3 is 9, so 9's a perfect square. So I can keep going with that. 16, 25, 36, 49, 64, 81, 100. I can keep going. 121, 144. I realize it's getting like a whole bunch of numbers, and we've already found the one that will work. But I like to have kind of a running or a basic knowledge of them at least through 15. So if you can know them pretty well off the top of your head at least through 15, that'd be useful for you. But if I look at 20 and I think about numbers that can multiply to give me 20, one of which has to be off that list over there, 4 times 5 is 20. So the root of 4 times the root of 5 would equal the root of 20. So if I can break it into that, the one that's perfect, the 4 in this situation, can become a whole number, and then the root 5 will stay under the radical. So the square root of 4 is 2. So this becomes 2 square roots of 5. So the simplified answer of this would be 2 root 5 and negative 2 root 5. You might also see this written as positive or negative 2 square root 5. Sometimes you'll see it written with the plus or minus in front of it to show positive or negative. But you can separate it into 2 separate pieces as well. So either way would be an acceptable answer to that. So you only have to do that simplifying the radical thing, first off, if it's possible to simplify it. Secondly, only when that number that's going to be under the radical can't be calculated into a whole number. So if it's going to be a crazy, ugly decimal, you want to check to see if it can be simplified before you give your final answer. All right, looking at this one. Kind of in the same situation here where our squared term is not by itself yet because there's a 2 attached to it. So I'm going to want to move the 2 before I can undo the square. And so because the 2 is attached with multiplication, I can divide by 2. And so I get that n squared equals negative 72. And so at that point, I'll do square root. So square root cancels the square. I'm left with n. What is the square root of negative 72? Well, if you go and try to do it in your calculator, you're going to get an error that says, error, non-real answer. Here's why that happens. You cannot find the square root of a negative number because there's no way to multiply a number by itself and get a negative number. Because if I multiply a negative number times a negative number, I'm going to get a positive number. If I multiply a positive number times a positive number, I'm going to get a positive number. So there's no way to multiply a number by itself and end up negative. You'd have to have one positive and one negative to do that, and that's not what a square root is. A square root is a number that can be multiplied by itself to get the original number. So for this situation, square root's not possible. This has no solution. So when you take Algebra 2, you'll learn about what they call imaginary numbers or non-real numbers. And so you'll find a way to kind of do a workaround on that. But for now, for Algebra, we only work within the real number system. And so for us, this has no solution. All right, one more. Now, you might look at this one and say, well, this one equals a negative number too. Should I just go ahead and put no solution? You want to work it out till you get to the point where you find the square root before you make that decision. Because it's possible something changes in the problem when you work it. And if that happens, you want to make sure that you would notice it and be able to continue working if possible. So for this one, our x squared is here. We still got to get rid of that negative 5 that's attached to it. It's attached through multiplication, so we'll divide by negative 5. And so I end up with an x squared that equals positive 100, because negative 500 divided by negative 5 is positive 100. And so now it is a positive number. I can totally do a square root with that. So square root both sides. Square cancels the square root. And so x will equal the square root of 100. Square root of 100 is 10. So x will be 10, and x will also be negative 10. Okay, so that's how that's going to work. Try to get that back on there the way it needs to look. Sorry about the craziness. Let's do a few more of these together. Now we'll do some that don't have just the x squared. It has a whole expression squared. So we have to treat those just a little bit differently. Same idea, but slightly different way of working those out. So looking at this one, I already have the squared part of this isolated because this whole thing over here is squared. So I don't have to move anything before I do square root. Now, if you notice the one underneath it, the squared part is right here. The 3 is going to have to move on that before we can undo that squared part. But for the one that we're on right now, this one, we'll work to just undo the square to start with. So because the whole thing is squared, I can do a square root to cancel that square out. Square root cancels the square. Leaves me with x minus 2. If I square root on the left, I have to square root on the right. Square root of 16 is 4. Square root of 16 is also negative 4. So you're going to want to write down both possible answers and then work off of both of those to figure out your two possible solutions to this. So I have x minus 2 equals 4. I have x minus 2 equals negative 4. And so when I work this out, I'm going to work off both. So to move that 2, I would just add 2. So I'm going to do plus 2 here, plus 2 on this one. So we're adding 2 to everything. X will now equal 4 plus 2 is 6. X could also equal negative 4 plus 2, which is negative 2. So x can equal 6 and x can equal negative 2. Those are my two solutions. All right. Since you're already here, and I already highlighted on this one, go down to the one underneath this one, and then we'll go across to the other side. So I'm working on one like this, same idea, But I'm going to have to get the squared part by itself first. So that 3 is being multiplied to the 3x minus 8 squared. What you don't want to do is to try to distribute that into there. So I'm not trying to distribute this here because really I would have to work out the square part of this first, which means I would have to make a box or have to FOIL to multiply that out and then distribute the 3. And then I've messed up really, maybe not messed up, but I've kind of undone the part of this that would be easy to solve because it's already squared. And I would have to then turn around and factor it, which we're going to do later. And that wouldn't really be a great option. So best thing to do in this situation when there's a 3 attached to all of this through multiplication is just divide that 3 off. So I'm going to move the 3 by dividing it, which will leave me with 3x minus 8 squared equals 1, because 3 divided by 3 is 1. Now that the squared part of my equation is by itself, now I can take the square root. So again, the square root's going to cancel the square and leave me with 3x minus 8. The square root of 1 is 1, but it is also negative 1. So I'm going to finish working this out using both of those possible answers. So 3x minus 8 could equal 1, 3x minus 8 could equal negative 1. To solve that, I would start by adding the 8. So I'm going to add it to both possible answers. And so I have 3x that comes down. 1 plus 8 is 9. Negative 1 plus 8 is 7. And then we finish this with division by 3. So everything divides by 3. And that'll leave us with x equals 9 divided by 3 is 3. 7 divided by 3 comes out to be a 2.3 repeating crazy decimal. And so we're going to just leave that in fraction form as 7/3. And that would be our 2 solutions to that. All right, we'll do a couple more together and let y'all try a couple. On to this one. So this one, the squared part is already isolated. We have this x plus 4 that is squared. There's nothing I need to move off of that side. So I just need to work on getting rid of the square so I can finish solving the equation. So I'm going to undo the square with a square root. That cancels out. It leaves me with x plus 4. The square root of negative 3 does not exist. There is no square root for negative 3. Negative numbers have no square root. So this is no solution. This is not real. All right, one more together. Looking at this one. So here's the part of my equation that's squared. This is the squared piece. Which means before I do this, I need to get rid of that 1/4 that's on the outside of those parentheses. Again, not distributing that 1/4 because that's going to mess up what I've got going on here. I'm just going to get rid of it by dividing it off. Remember that dividing by 1/4 is the same thing as multiplying by 4. So if you'd rather just multiply by 4, that's good. It's the same thing. And so my 2x plus 1 squared comes down. 1 divided by 1/4 or 1 times 4 would be 4. And now I'm ready to do square root because the squared part of my equation is alone. So I'll take this and square root both sides. Square root cancels the square and leaves me with 2x plus 1. The square root of 4 is 2, which means it's also negative 2. And so I'm going to operate off of both of those things at one time as I go to finish solving this. So 2x plus 1 equals 2, 2x plus 1 equals negative 2. We start working that out by subtracting the 1 from everything. And so I have 2x that will equal 1, and I have 2x that will equal negative 3. And then from there, all we have left to do is divide by 2. So everything divides by 2. And so x will equal a half, and x will equal negative 3 over 2. And those are my 2 solutions. All right, if you'll take a couple of minutes, and we're going to go to the next slide and let you try a few of these So what I'd like you to do is pause the video right here. Try these out and then come back to the video once you've finished and see if the answers you got are the same as the answers that I got. And if they are, then great, move on. If they're not, take a look closely at the work that I did, because I'm going to work it all the way out, and see if you can figure out maybe where your mistake was, where you messed up on what you were working on there. So go ahead and pause the video here, work those 4, and then come back and see if you were right. All right, we're back. Take a look at these and see if you were able to get the same answers that I got for those. So the first one was 2 and -2. By the way, you needed both answers to have that correct. So if you only wrote one, go in and add the extra one. For the second one to the right, I ended up with a 9 and a -9. Bottom left, I ended up with 1 and a -9. I realized that kind of laid on top of there. Ooh, I don't know what I just did. I was trying to move that, but that should say a -9. And I can't erase it now, but anyway. And then the last one was not real because you ended up trying to take the square root of a -4, which is not possible. So we left that one alone. All right, hopefully that went well for you, so we'll move on. So next thing we're going to look at is how to do something called completing the square. And so this goes back to thinking about what we did when we were factoring and we were learning about those perfect square trinomials. And so if you remember, if we had a perfect square trinomial problem, we could do something that we called quick factoring, or using the perfect square trinomial formula to be able to factor those very, very quickly. And so remember to recognize something as a perfect square trinomial. The a, x squared, and the c have to both be perfect squares. And the b, the middle term, has to be 2 times the product of the root of a and the root of c. So to be able to look at these and know if they're perfect square trinomials, that's what we need to check for. So looking at this, x squared is a perfect square. 16 is a perfect square. So I've met the first requirement. Second requirement is that b is 2 times the product of the root of this and the root of that. So the root of x squared is x. The root of 16 is 4. 4 times x is 4x times 2 is 8x. So this one is a perfect square trinomial. If you remember when we learned how to quick factor those perfect square trinomials, we could just quick factor them into the root of a, the root of c, bring down the sign from the middle, and have that squared. So that one is a perfect square trinomial. It can do the quick factor. Look at this one underneath it. So 4x squared is a perfect square. 25 is a perfect square. The question becomes, is what's in the middle 2 times the roots of those? So the root of 4x squared is 2x. That's way bigger than I thought it was. I guess because I'm zoomed in, just kidding. So this is 2x. The root of 25 is 5. 2x times 5 is 10 times 2 makes 20. This one's got a 10 in the middle. So this is a no. So we can't quick factor this one. We would have had to get a 20 in the middle for that to work, and we did not get that when we... Again, you're checking that number by multiplying the root of this, so 2x, times the root of this, so 5, and then doubling what you get there, times 2. So 5 times 2 is 10, times 2 makes 20, not the 10 that I originally had in the middle. So that was not a perfect square trinomial. All right, do a couple more. Uh-oh, frozen. Not frozen, just doing the wrong thing, my bad. All right, looking at this one, let's check this and see if it works. So again, x squared is a perfect square, 9 is a perfect square. So I can check to see if the middle works by finding the root of each one. So the root of x squared is x, the root of 9 is 3. 3 times x is 3x, times 2 makes 6x. This one's got a 2x in the middle, so this is also no, not a perfect square trinomial. Cannot quick factor that. All right, on to this last one. 9x squared is perfect, because 9 is a perfect square. 49 is perfect, because 49 is a perfect square. The root of 9x squared would be 3x, because the root of 9 is 3. The root of 49 is 7. And again, to check it, we'll do 7 times 3x makes 21x, times 2 makes 42x. And indeed, we get what we needed, so this one is a yes. So since this one is perfect, we could quick factor it if we wanted to into 3x plus 7 squared. And that comes from the root of that first term, the root of the last term squared. All right. So thinking about all of that now, let's look at how to do what we call completing the square, which means we're going to make something that's not a perfect square trinomial into a perfect square trinomial. So creating a perfect square trinomial involves deciding what value goes in for c. That's called completing the square. So to determine what c should be, all we have to do is take the b value, which again, remember that the b value is created by the root of a. It's really not the root of a, it's really the root of the a squared. But it's created by doing the a times the c times 2. So if I'm trying to figure out what the c was, if I can divide the b by 2 times the a, then we're going to be able to figure out what c should be. But c has to get squared to go in the actual formula, so we're going to square that when we get done. All of the problems that you're going to see on this are going to have coefficients of 1 on the a. It is possible to end up with something that has a coefficient of something greater than that. You would have to then divide that by the root of that coefficient, which we won't deal with things like that, but it is possible that comes up. So to determine what c should be, we're going to divide the b value by 2. Divide the b by 2. And then we're going to square it so that we can create the c that would have originally been in the problem. Because remember, the c in the problem is squared. We found the square root to be able to use it for things. But it is squared when we have it originally in the problem. All right. So let's look at some examples. We're just going to complete the square first, and then I'll show you how to use that to solve some of these kinds of problems. So notice here they have x squared minus 38x plus c. We're trying to figure out what c should be. So that's our question mark. That's what we're trying to determine. That's what completing the square is. So to figure that out, we take our middle term, because that's our b. We start out by dividing that by 2. It doesn't matter if it's positive or negative. I put the negative on there, but it really doesn't make any difference. Take that back off, actually. So 38 divided by 2 is 19. And then we're going to square that. So 19 squared is 361. So c would be 361 for this problem to be a perfect square trinomial. So we half it, and then we square it to figure out the c. That's completing the square. All right, so on this one, to complete the square here, again, it's all about that middle number. So we're going to take the middle number, 24. We're going to half it. Gives me 12. Then I'm going to square that 12, which is 144. So for this to be a perfect square trinomial, we need to have a 144 in for c. Now, if you ever run into a situation where you have a coefficient other than a 1 on your squared term here, you want to divide everything by that number before you start. And that'll allow you to have a coefficient of 1 that you can just do, complete the square this way. Oops, just kidding. All right, let's look at this one. So my b term this time is 14, so I'll do 14 divided by 2, which is 7. 7 squared, 49. So to complete the square here, I'd have to have a 49 in place of c. All right, one more. So with this one, middle number is 10. So same deal, 10 divided by 2 is 5. 5 squared tells me my c would have to be 25. So completing the square in a problem like this should be very simple. It's the same process over and over. Let's let y'all try a couple of those, and then we'll come back and look at how to actually solve quadratics with this particular method. So if you will, pause the slide right here. Take a minute, calculate the value for C for each one of these, and then unpause, come back and see if you were correct. All right, go ahead and take a look at those and see if you're able to come up with those same answers. I feel pretty confident that you were. Remember that your C values are always going to be positive, because anytime you square a number, whether it's a positive number or a negative number, it's going to turn it positive. So if you gave any of those as negative numbers, go back and fix that. You shouldn't have any negatives when you're completing the square in the position of C. All right. So let's look at how to use this method to solve a quadratic. So if we can complete the square, and then we can quick factor those things into that factorization with the square on the outside of the parentheses, we'll be in a position where we can use square roots to solve. And so that's going to be our goal here. Complete the square so that you can quick factor, and then use that quick factorization to be able to do square roots and solve the rest of it. So arrange the quadratic so that the ax and the b terms, or ax squared and bx terms, are on the left side, and the c term, the constant term, is on the right. Because you need to have that space empty so that you can complete the square. So we're going to move the c to the right side of the equation so that the space where we're completing the square can be empty and we can have a spot to complete it. Then you're going to complete the square and fill in the c. If you add that number on that left side of the equation, which is what we're doing, we're adding that in the place of c on the left, you're also going to have to add that value to the right side. So we're going to add that value to both sides of the equation, because what you do to one side, you have to do to the other. A lot of times kids forget to do that, so don't forget you have to put it on both sides of your equation when you go to add that in. Then you're going to factor, or you're going to solve using factoring, so we'll quick factor it, and square roots. So here's what I mean by that. If you have a problem like x squared minus 8x plus 10. Nope, not plus 10. Let's say minus 10. Equals 0. And I ask you to solve this. So you're going to start by getting that space where that minus 10 is empty so that I can complete the square here. So I'm going to start by adding the 10 on both sides. That gives me x squared minus 8x plus something. And that's going to equal 10 plus that same something. So I like to go ahead and draw my box on both sides so I don't forget that I got to add it to both sides if I know I'm going to be doing complete the square. So that might be a good strategy for you to consider. So then we'll actually do the completing the square to figure this out. So I'm going to take my middle, my negative 8, and I'll divide it by 2. And then I'm going to square it. So I'm going to get 16. So I'm adding 16 on both sides. Let's make believe that this was a 20, not a 10. And so I add 20 on both sides. That's going to make my numbers work out nice and pretty. They don't always work out nice and pretty, but for this very first example, let's let that work out. So the right side of this, where I have the 20 plus the 16, is just going to come together and make 36. The left side of this, we can quick factor with the square on the outside using the roots of the a and the roots of the c. So remember that the root of x squared is x. The root of 16 is 4. I bring down the subtraction from the middle because that's how I know what sign goes in the middle. And that's my quick factored form of this problem. And so once I'm there, all I have left to be able to solve it is to do square roots on both sides. So I'll have x minus 4 because the square root canceled the square. The square root of 36 is 6, but it's also negative 6. So I now have my two possible answers there. Just have to finish this out by adding 4 on both sides. So plus 4 plus 4. And I end up with an answer of x equals 10 or x equals negative 2. Those would be our two solutions for this quadratic equation. So that's how we're solving with completing the square. All right, so let's go look at some examples of this. So here's my first one. I'm going to do the same thing with this that I just did on that last one. Start out by emptying the place where C goes. So right now there's a -3 in that spot. I'm going to move that -3 to the other side by adding 3. So that gives me a squared plus 2a plus something, which will equal 3 plus that same something. I have to figure out what that something is. So, it's going to move that up. That didn't quite work the same way that other things do. All right, whatever. So now to figure out what goes in that box, I take my middle, which is 2. I'm going to half it. And then I'm going to square it. So 2 divided by 2 is 1. 1 squared is 1, which means I'm going to add 1 on both sides. So on the right side, 3 plus 1 is 4. On the left side, I'm going to quick factor that using my perfect square trinomial formula. So the root of a squared is a. The root of 1 is 1. It's plus in the middle, so I'm going to bring down my plus. I've now done a quick factor on that. So I've used the shortcut method to factor it. So now I have a square term. I can do square roots. Square, square. A plus 1 is left behind. The square root of 4 is 2. It is also -2. And so to finish this out, I'll just subtract 1 from everything. And so I end up with A equals 1 and -3. I realize that this slide looks like it doesn't have enough room on it, and that's my fault because I meant to delete those bottom 2 questions because I put them on the slide after this. So I'm actually going to just, maybe I'll just draw over them with an empty box and make them go away. That didn't work. That's a line. Just kidding. I don't know. Anyway, we're not going to do the ones on the bottom of this. We're going to move them to the next slide. That way you don't have like a million things written on one slide. So I'm going to scratch those and scratch this one. And we'll do them on the next slide instead. I don't know if that gives us any more room because now we have a big old blob in the middle of our thing. But whatever. Okay, on this one, follow the same strategy. Start out by emptying your C. So subtract 12, subtract 12. Figure out what goes in the square and add it to both sides. So if I have 8 in the middle, 8 divided by 2 is 4. 4 squared is 16. 16 goes in the box. So I end up with -12 plus 16 is 4. Over here I'm going to quick factor. The root of k squared is k. The root of 16 is 4. There's a plus in the middle. So I have k plus 4 squared equals 4. And so then we'll do square roots to finish this. K plus 4 will equal, the root of 4 is 2. The root of 4 is also -2. I don't know why I changed this to black. All right, so I have 2 possible answers here. To finish out figuring out what they actually are, I'm going to subtract the 4 off of everything. So K will equal -2 and -6. I know it feels like a lot of work. It's really not super difficult, but you do kind of have to keep up and keep track of what you got going on there. All right, moving on. So again, these are the same ones off the bottom of that other slide. I just moved them to this slide and forgot to delete them off the other slide because it destroyed my life. So this one, same deal. We're going to start by moving the 21. And so I have p squared minus 8p plus something equals negative 15 plus that same something. Got to figure out what that something is. So take my 8, half it, square it. It's going to give me 16. So 16 is going to go in the box on both sides. So again, that right side just combines. Negative 15 plus 16 is 1. On the left side, we quick factor. P squared becomes P, 16 becomes 4. Bring down my subtraction that's in the middle. And I now have a problem I can do square roots. So square root gives P minus 4. Square root of 1 is 1 or negative 1. And then we can add 4 on both sides. So P will equal 5 and 3. All right, one more together, and then I'm going to let y'all try a couple of these. All right, in this one, we're going to do the exact same thing we've been doing. So again, we got to empty our C first, plus 48. So we end up with m squared plus 2m plus something is going to equal 42 plus something. So we'll take the middle. 2 divided by 2 is 1. 1 squared is 1. So I'm going to add 1 on both sides. 42 plus 1 is 43. This side will quick factor into m plus 1 squared. Because the square root of m squared is m, square root of 1 is 1. And then we'll be able to do square roots to solve this. So square root cancels a square. I get m plus 1. Now, 43 is not a perfect square. And so if you do the square root of that, you're going to get some crazy number like 6 and some change. And so again, we don't want to write those out with decimal values. We want to either leave it in radical form, or if it can be simplified or reduced, reduce it. 43 is prime. It does not have any factors that are perfect squares that will multiply to get it. So it's going to have to stay root 43. So we'll have the positive root 43 and a negative root 43. I don't know why that does that. Sometimes it makes it where I can't erase it, and I don't really know what the deal is, but it's okay. So then to finish solving that, we'll just subtract 1. So here's how that looks. M is going to equal the root of 43 minus 1 and the negative root of 43 minus 1. And we just leave it in that format. Now, you could see this written in a couple of different ways, and so I just want to show you that in case you're looking at a multiple choice test, you're looking at a ACT or something like that, and the order of this is different. So sometimes you'll see this written as the minus 1 will be in the front, plus the root of 43, and minus 1 minus the root of 43. So sometimes you'll see it like that. You also could see this as negative 1 plus or minus the root of 43, which means it could be both. It could be negative 1 plus that, it could be negative 1 minus that, and that's going to give the same answer. So either one of these options is a possibility. You want to be familiar with all three because you don't know how they might ask it of you later. And again, those kinds of things only apply when the number can't be reduced into a whole number that you can just work with. Okay. So I'd like you to take just a minute and try these two. And then you'll pause the video to do it. And then you'll come back to the video and see if you were correct in what you got. If not, again, you want to look closely at the work so you can see if you can figure out where your mistake was. And then when you finish those, go on and do the test prep on the next slide as well. And so when you finish all that, come back, unpause the video, and see whether you were correct or not with all three. All right, take a look at these and see if you got the same thing that I did. Here's the first one. I got the root of 34 plus 5 and the negative root of 34 plus 5. Again, if you chose to write that as like 5 in the front, plus or minus, that's way bigger than I intended. Five in the front, plus or minus root 34. That's fine as well. Make sure you have both possible answers in that scenario. All right. On that second one, you should have gotten a negative 3 and a negative 7. Again, if you missed that, look back over my work and see if you can figure out where you went wrong. And then on the last one, you had to complete the squares. So you have the 16 to get 8. 8 squared is 64, so you would have added 64 on both sides. When you add 64 on that right side, negative 8 plus 64 gave 56. So make sure you have this here, not just a 64, and have that combined value in both of those. All right, that's the end of that lesson. So if you will, make sure you submit your notes, and you're ready to do the practice. Y'all have a great day.